We'll proceed on various coordinate systems, and we will see more on two ways of integration. Calculus, you are amazing. Vector, you are amazing. Algebra, you are amazing. So, calculus, you are amazing. Vector, you are amazing. And algebra, you are amazing. So, in the past, we saw that in spherical coordinate system, we can calculate the volume of a sphere. If I have a sphere, then volume of the sphere we calculated through two integrations, two ways. One is through dV, that is a small volume we took dV, and then we did a kind of expansion, or we did kind of taken for the full limit, and we calculated the volume of a sphere. Now we proceeded and we calculated the volume of the sphere with the fxy as the height, fxy and d area. D area, fxy, then we calculated the volume. Two ways we calculated the volume. Can we calculate in two ways the volume of a sphere through cylindrical coordinate system? Means what the technology what we are using now, the technology that we are using now. Okay, the technology that we the technology that we are using now, so that is kind of layered approach. If I am tackling something at vector level that gives me direction, then tackling has to happen at vector level, calculus level, algebraic level. What is algebraic? Algebra is a actual function that gives me a curved surface or curved line of a sphere or of a circle. Okay, so algebra is responsible for actually drawing the points along the surfaces or the line. So whatever the curve we get, that is through algebra. Vector at any point gives the direction, whereas calculus, if the curve represent rate of change, rate of collection, then integration gives the net collection. Integration works on algebra. Integration works on algebra, whereas vector works on independent component. Independent component, if it is a scalar, then it is a static vector or position vector. But if they are, if if there is a vector, and if vector is f and f1, f2, f3 are independent component, if they are scalar, then this is kind of a static vector. But if they are variable in the sense they are algebraic equation, then it is called vector field. If algebraic equation is in function of independent components, then it is a vector field. If algebraic equation are a function of only one independent component t, then it is called parametric vector. So this is the difference between vector field and parametric vector. Now again, I won't demonstrate much what we did in a spherical coordinate system. Let's calculate the volume of a sphere volume of a sphere through cylindrical coordinate systems. Okay, I'm trying to search the ball, but ball is not there. Anyway, I have I have kind of I have kind of one sphere I have in my hand. So this is a sphere and I don't think it will go inside it. So I have got another cylinder. So consider this as a cylinder. Okay. So consider this as a cylinder. Now a sphere is inside the cylinder. Sphere is inside the cylinder. So we will follow cylindrical coordinate system to get the volume of a sphere. That is the concept. Can we calculate the volume of a sphere based upon the cylindrical coordinate system? So that is the idea. Volume of a sphere through cylindrical coordinate system. Now, as far as integration is concerned, then we saw that there are two ways. These are not available anywhere else. Repeatedly, I am saying these are not available anywhere else. Two ways of integration. So, one way is we have infinitesimal small volume and then make a limit of it. Other is I have a function like if I have a x-axis and there is a function over x that is fx. If there is a function over x then it is fx. Fx is vertical and x is independent component function over x. Okay. Now if I want to calculate the area, understandable, right? So if I have x-axis, if there is x-axis and there is a function over x fx. So fx is drawn like this, some function. Now, if I do the integration of fx along x-axis, then it gives me the area, the surface area. If I like fx is x, fx is x square. X square means the fx would start from 0 and it will go like this. Fx is x square. Okay. So this is x-axis, then fx x square would be like this, like a diode curve. Okay, so x-axis and x square. So fx is equal to x square. Then what is the integration? So if this is fx, then any moment if I'm calculating integration of fx, it will come as algebraic equation. If it comes as algebraic equation, then at any point, if I'm taking this point for the integration, then from this point down, x-axis is this, and this is the origin, x here. Then whatever the area underneath, that is the integration. So if fx is x square, then integration is x to the power 3 by 3. If that is the case, if integration is x to the power 3 by 3, if that is the case, then what is the, when x is 5, if x is 5, then 5 into 5, 25 into 5, 125, 125 by 3. So it will come as 5 into 5, 25, 125. So 125 by 3, whatever it comes, then that is the area underneath if I have a line that is x square. Okay. So integration is nothing but a way to calculate the area and in 2D. So consider this is not x-axis, this is xy plane. XY plane. There is one independent called XY plane. If it is XY plane, then there is a function on top of it called, so XY plane is really a plane. It is a plane. If it is a plane, then there is a function over it that is called fxy. Then fxy is a surface. If xy is a plane, then fxy is a surface. If I calculate the integration, if there is a surface and there is xy plane, integration will give me the volume. Okay, that is the concept. So if I want to get the volume of a sphere in cylindrical coordinate system, then a sphere, the equation of sphere, what it would be in cylindrical coordinate system. So now this is one way. Other way is in sphere. I'll take a small dv. Sphere is centered at the origin. Sphere is centered at the origin. From the origin, if I draw a radius, if I draw a line, radius, and if it touches the outer layer, if it radius is touching the outer layer, then radius is small a. Consider small a. But it is not going complete small a. In between, there is a radius r. If there is a center, from center, there is a radius r. If there is a radius r, small r, then at radius r, I have a small volume dv. What is the volume of dv? The volume of dv is nothing but the surface area into height. That is the cylinder. Surface area into the height. So surface area, if I see, then it is pi d theta, sorry, r d theta dr. R d theta dr is the dA. dA into dz is the volume in cylindrical coordinate system. So dA, if I see in cylindrical coordinate system, that comes as polar coordinate. So r d theta dr, and then height is dz. So r d theta dr dz. That's it. So that is dv. Now we have dv. Now triple integral, because three variable independent variable we have taken, dr, d theta, and dz. From the traditional actual calculus is function and d of the independent component. So function is fxy d xy plane. Then double integration. Two ways we have to calculate the volume of a cylinder. Let's go with the dv method. So that is triple integration d of the volume, small volume, that is delta v or dv, that I have to place limit and I have to calculate the integration. So dv is r d theta dr dz. So simple, right? R d theta dr dz triple integration. Now let's start with the r d theta dr dz. So r dr d theta dz we can make. If that is the case, then it is r dr. R dr integration is r square by 2. If that is the case, what is the limit? Limit is 0 to a, not a. Because r is variable. Okay, r and z has dependency. If we see a sphere, if we really have cylinder, then r is 0 to a full and z is, both are independent. But if it is a sphere, if you see, if it is a sphere, then any moment, if I cut at, if it is centered at xy plane, if I cut it at xy plane, the radius is a. That is the radius of a sphere. If I cut it here, top, then again there is a circle and radius is not a, smaller than a. If I cut at top, then there is no radius. Okay, radius keeps increasing, and at xy plane, at the origin, it is maximum, that is a. If that is the case, then if I cut anywhere, then what is the radius? What is the radius? Consider radius is r, small r. This is what we have taken here. So r and height is z. If I cut it here, okay, this is the maximum radius. If I cut it little top, then there is a height z, and if I cut it, then there is radius r, and there is a diagonal is a, that is the radius of the sphere. So diagonal is a, and then top radius is r and height is z. This proves that r equal to a square minus z square, square root. Hypotenuse square equal to height and width. So a square equal to r square plus z square. So r equal to a square minus z square, square root. If that is the case, now I have to put limit of radius from 0 to square root of a square minus z square. Now here we have r square by 2 is the integration. So it will be converted to a square minus z square by 2. dz d theta dz d theta, it will, so theta is in xy plane, we rotate the full to theta 2 pi degree. Okay, so if I rotate full, then it is 2 pi degree. So d theta integration is theta 0 to 2 pi. So 2 pi into a square minus z square divided by 2. 2 gone. Pi is constant now, I can keep outside. A square minus z square dz. Now a square z minus z to the power 3 by 3 is the integral. So a square z minus z to the power 3 by 3, where z is 0 to a. Top is the radius a, 0 to a. So it is a to the power 3 minus z to a to the power 3 minus a to the power 3 by 3 to a to the power 3. So volume is 2 pi a to the power 3 by 3 whole 3. So we, if the z value we had taken from 0 to a, I can take minus a to a for the complete z value. So whatever we have got, we have to just double it now, because we have calculated for the top hemisphere. So if that is the case, then it is 2a 2 pi a to the power 3 by 3 into 2. So 4 pi a to the power 3 by 3 is the volume of this sphere through the one integration with cylindrical and spherical. Sphere inside the cell. These are not available anywhere. Okay. And what I am going to talk now, certainly it is not available anywhere. So this is one way we have infinitesimal small volume dV, and that dV we covered for the full sphere. What about the volume of a sphere through actual calculus? That is, I have a xy plane as independent component, only one, not x-axis and y-axis. XY plane. I have a function over xy fxy, that is vertical, and it is a sphere. If I calculate the integration of fxy along the xy plane, it will give me the volume. So fxy d of xy plane would give the volume of the sphere in cylindrical coordinate system. Double integration because d of xy plane. So d of xy plane, or if I say single integration, then xy plane begin and xy plane end. Okay. Now d of xy plane, if I see in cylindrical coordinate system, the xy plane, if I cut it this at center, then it is a circle, polar coordinate. So r d theta dr. D of xy plane is r d theta dr, that is the dA. And what is fxy? Any moment, what is the height? That is fxy. So height is nothing but a square minus r square. This we have talked nicely. So if I make a cross section anywhere top, middle, not at the center, somewhere, then it will be again a circle. Height is z and radius is r, then hypotenuse is a, that is the actual radius of a sphere. So the height, that is fxy. So height is nothing but a square minus r square root. If that is the case, then we want to calculate square root of a square minus r square d, okay, r d theta dr. Okay. Now r is from 0 to a. R is not a function of z, because we are completely dissociating the height and surface area. So r is from 0 to a, and theta that rotates. See the polar coordinate system. Everything we have explained. So polar coordinate system, theta is 0 to 2 pi. So 0 to 2 pi. Now let's integrate a square minus r square r dr d theta. So r into a square root of a square minus r square is nothing but minus a square root of a square minus r square. R into a square root of a square minus r square integration is minus a square root of a square minus r square. If that is true, Then if I calculate the differentiation of this, a square minus r square square root, then 1 by 2 will come out first. Okay. I'm sorry, differentiation, integration of r square root of a square minus r square is a square root of a square minus a square minus r square. This is what we are saying. If that is true, then a square minus r square to the power 1 by 2. So if I differentiate it, then okay, if I differentiate it, then it will come 1 by 2, and then again 1 by 2 a square minus r square. Okay, so is it not true? So r square root of a square minus r square, for which I have to calculate the integration. So if I say that it is square root of a square minus r square, then square root of a square minus r square, if I do differentiation, then if first I differentiate with a square minus r square, then it will come as 1 by 2, and then a square minus r square minus 1 by 2. Okay, differentiation will, it will do minus. So minus 1 by 2. So this is not true. What we have said is not true. So integration of r, a square root of a square minus r square would be minus 1 by 3 a square minus r square to the power 3 by 2. That is the integral. If that is the case, then a square minus r square to the power 3 by 2, if I do differentiation, 3 by 2 a square minus r square root into minus 2r, minus 2r. So 3 by 2, 3 gone, 2 gone, and then minus gone. So r square. So integration of r, square root of a square minus r square is nothing but minus 1 by 3, and in braces a square minus r square power 3 by 2. If that is the case, then it is the integration. Now if I place the limit 0 to a, then it will come as, first a is 0, a means a square minus r square 0, and 0 if I place, then it will become, minus will go away, it will become a to the power 3 by 3. A square minus r square, r is 0, so a square, and then 3 to power 3 by 2 is the power a to the power 3. So a to the power 3 by 3. So minus will go away, a to the power 3 by 3 is the integration. Now we have theta 0 to d theta 0 to 2 pi. So 2 pi. So 2 pi a to the power 3 by 3 is the volume of the sphere. But it is again hemisphere, because fxy that we have taken z value, that is from the xy plane. So upper half we calculated 2 pi a to the power 2 pi a to the power 3 by 3. So it will be 4 pi a to the power 3 by 3. That is the volume of the sphere. So we calculated the volume of the sphere through cylindrical coordinate system in two ways. Okay, one is through dv, a small, infinitesimal small volume, and that is triple integration. And then another is that single fxy along with a dA, d of the area, single integration, not triple, single. That become r d theta, so we took double integration. So this is the concept of kind of calculating the volume of a sphere through purely into the cylindrical coordinate system. Can we calculate the volume of a sphere through Cartesian coordinate system? Okay, in Cartesian coordinate system, if I take, again we will go two ways, dv and then fxy d area. Okay, so if I take dv, then triple integration I have to take dv. What is the volume if I have a sphere? If I have a sphere, then if I take any small volume in Cartesian coordinate dv, then dv and triple integration. So small volume, if I take dv, then that is nothing but it is a cube dx dy and dz. So dx, dy, dz. Dx, dy, dv will convert into dx, dy, dz. Simple, right? And then triple integration. So now here, mind it that z is dependent component. Okay, I mean height is dependent component, though we are not taking care, and x, y are independent components. We are not taking care. So let integrate that z first. So dz, I have to integrate from z is, if I see this, then z is 0 to top. But z is dependent, and it is dependent upon x and y. How it is? The formula of a sphere, if I see the surface, then it is x square plus y square plus z square equal to a square. If that is the case, then z equal to a square minus x square minus y square square root. Z equal to a square minus x square minus y square square root. If that is the case, then so nicely that we have to place limit of z from 0 to square root of a square minus x square minus y square, because z is varying upon the x and y. So dz integration is z, limit is 0 to a square minus x square minus y square. That will come as square root of a square minus x square minus y square dx dy. Dx and dy are independent, so they will span from minus a to a radius and then minus a to a. So square root of a square minus y square minus x square dx, if I take the integration, then if I take x equal to a square root of a square minus y square cos theta, x equal to a square root of a square minus y square cos theta, then dx equal to a square minus y square root is constant. Cos theta will convert into minus sin theta d theta. So dx, I can now nicely I can write minus a square root of a square minus y square sin theta d theta. Now here I have a square root of a square minus y square minus x square. X square will convert into a square minus y square cos square theta. Altogether square root of a square minus y square would come out. And inside that 1 minus cos square theta, that is nothing but sin theta. So sin theta, sin square theta, d theta. A square root of a square minus y square, a square root of a square minus y square will result in a square minus y square. These are constants. So minus, and in bracket a square minus y square, I can keep out sin square theta d theta. Sin square theta d theta. The integration of sin square theta d theta is theta by 2 minus sin 2 theta by 4. You can check it. So I have not done, I have seen somewhere. So integration of sin square theta is x by 2 minus sin 2 theta by 4. Now limit is, if I have a sphere and x is minus a to a, if I take in theta, then that will be minus pi by 2 to pi by 2. So minus pi by 2 to pi by 2. So theta by 2 minus sin 2 theta by 4. Sin 2 theta. So pi by 2 will convert into pi. Okay, and this pi by 2 again. So sin pi is 0. So that component is gone. Only theta by 2 remains. So theta by 2, pi by 2 means pi by 4. Pi by 4 plus pi by 4 will be pi by 2. So pi by 2 is the net integration. So pi by 2, now pi by 2 into a square root of a square minus y square. There is a minus sign here. So square root of a square minus y square. I'm sorry, there is no square root. A square minus y square. Here pi by 2 came into the picture. Okay. So pi by 2 came into the picture. Now a square minus y square. So pi by 2 will keep it outside. Now a square minus y square dy. Okay, if that is the case, then a square integration a square minus y square would be a square y minus y to the power 3 by 3. Y is going from minus a to a. So if I substitute a there, then a to the power 3 minus a to the power 3 by 2, 3 by 3. That is 2 a to the power 3 by 3. Okay. Now minus a to a means double I have to do. So that is pi, that is 4 a to the power 3 by 3. Now here pi by 2 was there, 2 will go away. Now it is 2 pi a to the power 3 by 3. There is a negative that someone has to take care. Anyway, that has to be seen. So it is now 2 pi a to the power 3 by 3. Again, we have calculated for the hemisphere because the z value I had taken square root of a square minus x square minus y square, 0 to I had taken 0. At the initial integration, the z I had taken 0. I should have taken minus square root of a square minus x square minus y square to square root of a square minus x square. So hemisphere we calculate. So hemisphere volume is nothing but pi 2 pi a to the power 3 by 3. So full sphere is pi 4 pi a to the power 3 by 3. So we calculated the integration volume of a sphere in Cartesian coordinate system through dV. Let's calculate through fxy d of the area. So fxy is nothing but z, that is again square root of a square minus y square minus x square, and then the dA, the xy area plane, is dx dy. Same thing what we did earlier came into the picture, but it is so shortcut, right? Means fxy and the area. So fxy is the square root of, that is z, square root of a square minus x square. Okay, z square root of a square minus x square minus y square dx dy, where a is from minus a to a, x is from minus a to a, and y is minus a to a. If I fxy, if I have taken a square, square root of a square minus x square minus z square, then it will give the, because from the xy plane we have taken the sphere, so it will give again result for the hemisphere. Now we have to multiply by 2 get the sphere. We will get the same result now, that is 4 pi a to the power 3 by 3. Now idea is that can we do now the kind of interoperability as far as two integration is concerned. I have dual integration, then can I do interoperability that I start with the Cartesian coordinate and end up in the spherical coordinate. This is hybrid model. Okay, I start with Cartesian coordinate and end up in cylindrical coordinate. So this is hybrid model. So hybrid model also we will calculate the volume, and that we will see.